Okay, so we're going to move to lesson 2. This is on page 425. And my video only lasts 10 minutes, so I have to do it in a couple lessons, but you can find the next lessons. I'll share those as well. So we're going to talk about equivalent forms of rational expressions. So the first thing we're going to do is just talk about how we used to reduce fractions, basically, is what you're doing. So when you do that, when you have 10/15ths, if I said write this in simplest form, you would reduce, you would find the factors that are common and you would reduce it. So it reduces by 5. So you would say, okay, 5 goes into 10 twice and 2/3. And so you actually, what we did is you could say you divided by 5 on the top and the bottom. What could be an equivalent form of 10/15ths? Another way to do it. Well, in the same way you can divide both of the top and the bottom by 5, you can also multiply. So we could multiply by anything you wanted. And as long as you do to the top and the bottom, basically you're going to go 10/15ths. We're going to times the top by 2 and the bottom by 2. Now really 2/2 is just a big 1. So we can do that and still have an equivalent fraction. So you can either divide the top and the bottom by 5, or you can multiply by any number that you want. And those are called equivalent forms. So it's nothing big or crazy looking. You can either multiply or divide. So here is where they show the 10/15ths actually being in factored form, which is what I like to teach. That you factor the 10 into the 5 and 2 and you cancel like factors. Because factors, that's 5/5 is actually a big fat 1. Sorry. It's a big fat 1. So that's much easier to do it that way. Now, if we go on down, it says determine an equivalent form of the rational number 18 and 42 by dividing. So if you want to divide, what divides evenly? 6 does, right? Let's divide by 6. So we would get 3/7. If you want to multiply, I don't know, maybe let's multiply by 2. So 18 out of 42, but we'd have to do top and bottom. So we have an equivalent form. So we'd have 36/84. Now, if we factored first, that would mean to break it into its parts. 18 could be broken into 6 and 3, and 42 could be broken into 6 and 7. Then you could cancel those like factors and get 3/7. So it says write a different answer for each of the parts in A. So you could do this lots of ways. Instead of dividing by 6, there are lots of ways that we could divide. I'm not going to go into that. Let's turn the page. Okay, so if we want to investigate equivalent forms of a rational expression, we're going to want to check out what happens. Are these two expressions actually the same thing? They don't look the same. One has way more information in it, the x squareds. But what happens if I plug in values? So if I plug in a value of 1 everywhere I see an x on the top of this, I will get a 2 times 1 is 2. And on the bottom, I will get 1 plus 2 times 1, which is 2/3. Well, what if I plug in 1 over here? You also get 2/3. So what looked like they were totally different, they're actually maybe going to be equivalent. Let's try again with another number. So if I take a 2 this time, and I want to put, everywhere there's an x, I'm going to put a 2. I will end up with 4/4 plus 4, which is 4/8, which is the same as 1/2. Let's try it again, but let's use the other expression. So everywhere I see an x, I'm going to put a 2. Oh, look at that. I get a 1/2. I'm not going to do the rest. I'm going to have you trust me that the rest of them are also going to be the same. So we have these two different looking expressions that actually, when I put in numbers, they give me the same answer. So I'm just going to say they're all the same. They're known as equivalent forms. the following procedure can be used to prove the two forms are actually equivalent. So what you want to do to prove they're equivalent is first factor the denominator, then reduce by dividing out or canceling the common factor. So here we started the work right here. 2x, we leave the top alone. We factor out the bottom x, which is common to both. That leaves us with x plus 2. Now the factor that can be canceled, this 2x on the top is actually 2 times x. And this x and that x cancel. And what we have left on the top is a 2, and then we have an x plus 2. And lo and behold, it's exactly the same. So this note says, when you are writing them in equivalent form, it is said to be in lowest terms or simplest forms when you have done everything. You have factored first. You must factor first and then cancel. And it says here, the 2's cannot be canceled because this 2, the number on the bottom is, this 2 is connected to the x. It's not alone. You can only cancel if they are multiplied together, not added, like this 2 is added to the x. So, big point. To reduce fractions, you divide out factors, or I'm going to say cancel factors, not individual terms. And I'll show you what I mean. Let's turn the page. Okay, so here they're saying, let's check out what happens if we don't cancel first. So if we might end up with some non-permissible values that are not the same in both. So if we just leave them where they are and we just start plugging in 0, I'm going to have 0 on the top here, and then 0 plus 0. So this is just a 0 over 0, which is not defined. You are never allowed to have a 0 on the bottom. But on the right-hand side, when I put a 0 in, that's not a problem. I end up with 2 over 2, which is 1. And that is allowed. So all of a sudden, I have in my original, I have a value for which is not defined. But in my reduced form, it's fine. So you must learn that you have to decide what your non-permissible values are before you cancel. So let's carry on with this. If I put in, let me just tell you that both of these work. So we're going to skip those. But let's plug in a negative 2. If I plug in a negative 2 everywhere there's an x, I'm going to get negative 2 squared plus 2 times negative 2. This is going to be negative 4, positive 4 in the bottom, minus 4, not defined. So it's not defined here. But what about the other side? What about the right-hand part? Let's plug it in. It is also not defined. So sometimes they will give you not defined in both places, but not always. So we're going to go down here and we're going to say, for which of the values of x is the expression not defined? If you were surprised, you shouldn't have been surprised. If you had factored this, you would have discovered that when you pull out an x, what you have left is x plus 2. So it is not defined when x equals 0 or negative 2. However, when we look at this simplified version, we discover that x plus 2 will not be defined when x is only negative 2. So we are missing the 0. So you must learn that you factor first, you pick your non-permissible values, and then you cancel. So if I could say those all, I would say factor first, pick your non-permissible values, and then reduce. Okay, so here is that stop sign that says that the non-permissible values of equivalent rational expressions must be determined before you cancel the factors. So let's not forget that.